Hello, good day, guys. You have learned about displacements, velocity, and acceleration when you were in grade 7 and 8. Now, you will use those basic equations to derive formulae used in uniformly accelerated motion. Let me change first the color of my pen. Okay, so we'll be using equations to derive formulae used in uniformly accelerated motion. Motion, or what they call the UAM. Okay, using the following equations on velocity, average velocity, and acceleration. You can derive other equations. Okay, so let's have first the equation A. Which is for velocity. V is equals to distance over d over t. Next, okay, so next is for the average velocity, and lastly acceleration. So let's have first the average velocity. It's equals to Vf plus Vi over 2. And for acceleration, for that, let us have first equation B. And for the last equation is for acceleration. So let's have A is equals to victory F minus Vi over T. Okay, so where these letters have their own meaning, okay, or acronym. Right, let me just move this next, where victory is equals is means velocity. Vf means final. final velocity. Next, for VI, means we have final, we have initial. After initial, we have a VAV, or what they call average. After VAV, we have D, means distance or displacement. After displacement, we have T, means time, and A, lastly, for acceleration. So, to find out how displacement changes, with time, when an object is uniformly accelerated, an object will be rearranging A to arrive at equation A here. Okay, so let's write this one here. This is equation A. Equation. Okay, so to arrive at D is equals to the product of velocity and time. Okay, so since the velocity of an object changes when it is uniformly accelerating, we use the average velocity, okay, to determine the displacement. Where's my cursor? Wait, there you are. Okay, so since the velocity of an object changes, okay, here, when it is uniformly accelerating, so we use the average velocity to determine the displacement. So by substituting victory here, we'll be substituting it by the average velocity using VAV. In equation B. So where's the equation B here? Okay, so this will be using this. Okay, substituting the victory for the d is equals to the product of um, velocity and time. So meaning for us to uh, to determine the displacement, okay, we will be substituting victory to average velocity. So we'll be writing it. Okay, so it's equals to Vf, or which is called as final velocity, adding it to initial velocity here, okay, over 2, okay, and time for multiplying the time. Okay, so this will be our formula for us to get the equation D. Okay, so for us to um, to determine the displacement, um, we'll be using average velocity, changing, replacing velocity, okay, in equation B. So let's move now to the next. Mm, Okay, so here are we now. From equation D, equation D here, which is from the equation A. Okay, so we derive it here. We derive the equation A to this one to find out how displacement changes with time when an object is uniformly accelerated. Okay, so this is a displacement changes with time. Okay, so how about sir? Will be um, determine the displacement from the equation D here. No, no, this is not the equation D. We just derived it from this formula, but the equation D is this one. Is the average velocity adding final and initial, okay, over 2, multiplying it to time. Okay, so rearranging equation C, okay, to arrive at final velocity is equals to initial velocity um, plus the product of acceleration and time. And substituting Vf, or final velocity, in equation D, you will get this one. Let's have first equation C. Um, what the? So equation C is A is equals to the um, the difference between initial and final velocity over time. Okay, so as we have earlier, we will be rearranging C to arrive at final velocity. Okay, is equals to um, is equals to initial velocity plus the product of acceleration in time. Um, Let us have this one first. This equation for D. Okay, so from the equation D, which is this one. Okay, so we will be substituting final velocity in equation D. Okay, so where's the final velocity? Here. This one. So it says we'll be replacing it to final velocity. Sorry, the final initial plus the product of acceleration and time. Okay, plus the initial velocity over 2 multiplied to time. Okay, so combining initial velocity, wherein we are having two initial velocities, one here and two here. Okay, so we have two initial velocities. So we'll be arriving by combining it is this one, 2vi, I'm sorry, plus the product of acceleration time over 2 multiplied to time. Okay, of course, we'll be distributing t and we'll have another equation which is more simplified. Distributing t. So we'll be combining this, multiplying this one. Well, not cancelling, but combining it. So as we combine this, we'll be eliminating the parentheses, of course. So 2vi, okay, will be emerging, wow, emerge, t to another t here, plus the product of acceleration and time squared over 2. Oh, not this one yet. Okay, so simplifying it further will provide us another equation, which is equation E. So, excuse me. So as we simplify, um, this number will be cancelled here. Okay, for equation E. So this will be like this one. So, sorry, I forgot to write t here. Plus, okay. Okay, so VIT multiplied the initial velocity multiplied to time plus the product of acceleration and time square over 2. So we'll be having this number, this formula. Okay, so this shows that the displacement of the body is directly proportional to the square of time. Okay, so this confirms that equal interval of time displacement increases quadratically. Okay, to find out how final velocity depends on the displacement. Okay, so let's move on to another one using the formula dvt is equals to v the product of velocity and time. So to find out how final velocity depends on the displacement, will be substituting v and t from the equations b or equations b and c. Equations b, sorry, we'll be substituting v and t from equations b and c. So what will be our equations b and c? Okay, average velocity, as we remember it, a is for velocity. Okay, velocity is equals to distance over time, is equation a. For b is the average velocity, wherein final average velocity Vav is equals to final velocity, the sum of final and initial over 2. And for the c, we have um, the quotient or the difference first over the difference between the final and initial over time. Okay, so as we said earlier, um, we'll be substituting v and t, victory and t for equation b and c. So these are the equations v, b and t, c. So I will be writing again. So for final velocity, we have the average velocity over 2 multiplied to, which is the formula for equation C, which is the acceleration difference between initial and final velocity. Okay, but we'll be using A here. Okay, so let's proceed. So recalling from our algebra when we were grade 7. So A plus B multiplied to A minus B will give us A squared minus B squared. This is how we solve this equation using the principle of algebra. Okay, so let me just erase this first. Oh wait. So A plus B multiplied to A minus B will give us A squared minus B squared. I guess I'll be erasing this first. Okay, so where are we now? So D is equals to final velocity squared here. So we have two square final velocities here. So we had the exponent. Okay, so we must square the two initial velocities and 2a because they are not the same number and they are not the same letters. Okay, so we'll just combine it. Okay, so we need to simplify this first. Okay, so simplifying this number, we'll be placing 2a multiplying or we'll just rearranging it. Okay, so we'll have 2ad is equals to final velocity square minus initial velocity square. Okay, of course, rearranging it will give us more detailed answer. Okay, so we're not yet done. To find out the final velocity depends on displacement. We must rearrange this. Okay, so by placing final velocity in at the very first, okay, here. So initial velocity is equals to initial velocity squared plus 2ad, which is the product. Okay, acceleration and displacement multiplied to 2. Okay, plus initial velocity squared. Okay, so this will be our equation F. Equation F. So for us to apply these derived equations, let us have a word problems. So let us have the sample number 1. Okay, so sample number 1, let me write the problem first. So an airplane from rest accelerates on a runway at 5.50 meter per second squared, okay, for 20.25 seconds until it finally takes off. The ground. So the question is, what is the distance covered before takeoff? What is the distance covered before takeoff? So let us have the given number here. So what are the things that we must have? Okay, so we have these numbers: 5.50, 20 seconds, and nothing more. So let us have this one, acceleration 5.50 meter per second. Okay, or square here. And the time will have 20.25 seconds. And for the initial velocity, which is not given, which was not mentioned earlier, um, which is considered as 0 meter per second. Okay, so this is the initial velocity, which is 0. So what we'll be finding is, it says what is the distance covered before takeoff. So meaning, what is defined? What the? Okay, so what will be the formula that we'll be using? Formula is we might have is the, wait, P is equals to VIT plus 1/2. What the? Plus 1/2 80 squared. So getting all the given numbers. So we'll just replace these numbers to the letters we have here below. Okay, so which is the initial velocity is, which is this one, is 0. So 0 meter per second. This is here for the initial velocity. Multiplied to time, which is this one, 20.25 seconds. What the? Plus this one, 1/2. So we standard. which is the acceleration. Where is it? This one, 5.50. So we have 5.50 meter per second squared. Multiplied again to time, excuse me, which is 20.25 seconds squared. 5 and s are the same. K squared. So we replace these letters to numbers, to our given numbers. So it's time for us to solve for this one. So let us have calculator here. Okay. Oh wow. So 0 meters, what the, multiplied to, so 0 meter, 0 multiplied to any number will have 0, which cancels this number, right? So what what's left are these numbers. So 1/2, let us write it first, 5.50 meter per second squared multiplied to 20.25 seconds squared. Okay, so let us multiply first 20.25. 20.25 times 20.25. So 410. For this number, we have 410. Point 06, point 0625. What the? Okay na lang. Okay, seconds. Okay. Multiplying it to this number, ganito na lang pala. I'm sorry. So 410 times 5.50 will give us, let me just erase this, to 2,000. 255.34375. Point 34375 is correct. Okay. Of course, we'll be dividing it by 2 because of this number, 1/2. So dividing this number, we'll be having 1.127. So the distance covered is 1.127. Okay, 0.67. Okay, so or we can round this number off to 1.130 meter. Okay, not point, not point this one. Okay, so the answer is 1,127. okay, meters. We'll be rounding this number off um to 1/130. Okay, so this is the answer. Next. Okay, sample problem number 2. Okay, so sample problem number 2. So a jeepney from rest. So accelerates uniformly over time of 3.25 seconds and covers a distance of 15 meters. So the question is determine how we're going to determine the acceleration of the jeep. So determining acceleration of the jeepney. So what are the given numbers here? So this one, and for this next one, 15 meters, which is distance, and we have time. The given given. So we have initial velocity, which is always set to 0. Displacement, which is 15, or distance. Time, which is 3.25 seconds. And we'll be finding, question is A, or the acceleration. Using the same equation earlier, which is formula, which is distance is equals to the product of initial velocity, product of initial velocity and time, plus one half the product of acceleration squared, acceleration and squared of time. Okay. We'll be replacing these numbers to their corresponding letters. Okay, so for distance, which is this one, we have 15 meters. Well, let us not forget writing the symbol used. So 15 m or 15 meter for the distance or displacement is equals to 0 meter per second, which is this one, set to 0 always, unless oh, unless the word problem gave you a value for initial velocity. We'll be changing the value for initial velocity if we have. So for now, we don't have any number for initial velocity. That's why this is always set to 0. And time, which is 3.25 seconds. Okay. Plus 1/2. The acceleration is the problem, but we'll just write a here, even though it is unknown yet. So 3.25 seconds for time squared. Okay, so again, multiplying any number to 0 will cancel. We'll cancel this. So we'll be having any zero product. Okay, so what is left is this one. So we'll try to rewrite this 1/2 uh, acceleration and time squared. Let us square first the time. 3.25 times 3.25. So when you see this number, you'll be multiplying the number itself. So it means 3.25 multiplied itself will give us 10.56. So 15 meter, 15 meter, 10.56 here, 5625, 5625 divided by 2, divided by 2 will give us 5.28 seconds squared. Okay. We'll be having a here. Okay. And rearranging the formula. We'll be finding a determining acceleration. So we'll be placing a in front at first. So 15 meter will be will change its position to this one, 15 meter. Okay, divided by 5.28 seconds. Okay. Ah, so let us try to answer 5.28. divided by 15. I'm sorry. 15 divided by 5.28 will be having 2.85 or 2.84 for acceleration. 2.84. We can have 2.8 meter per second squared. Okay. So, are you all following? Did you get the answer? So, solving this acceleration, okay, for us to get the acceleration here, we can explain this further by not replacing or changing its position by just writing the number here, canceling it here, and writing the 15 meter here. So this explains how did we get 2.84 as final answer. So we just write it right away. A is equals to 15 meter. Okay. Oh no, not this one. We'll be using this number 5.28 seconds squared. Okay, canceling this. Okay, so if we'll be using this one, we're not going to have acceleration which has the unit of meter per second squared. So it must have this this unit meter per second squared, meter over second squared. Okay, so I think that explains how we got 2.84 meter per second squared. Okay, so um, we'll be solving another for the last one. We're not going to answer this. I want you to answer this on a piece of paper and then passing it um, as if you're my student, you'll be passing it um, as I instruct you when. So for the last problem, a train or problem. Let's write problem. A train accelerates to a speed of 20 meter per second over a distance of 150 meters. So you have to determine the acceleration. Assuming this is uniform of the train. Okay, so